Hey guys, welcome back to lecture series on numerical methods. We have started lecture series based on the numerical method for differential equation for finding the solution of differential equation. Okay, and in my last lecture guys, I explained here Euler method. Okay, detailed Euler method and their iterations. Okay, so in my today's video guys, I'm gonna explain to you all one of the example based on the Euler method, okay, which is the previously repeated question from your SPPU question paper. Okay, so without further ado, let's get dive into today's lecture. First of all, I'm gonna explain to you all the example and then we go for the detailed solution. Okay, yes, now see that what we have given in our example. Now see that this question asked in June 22 and 19 for 5 marks, okay, in your SPPU question paper. So similar type of the questions are possible in your upcoming ENDSEM exam. Okay, yes, so what we have given in our question, use Euler method to solve dy by dx which is equal to x plus y of 0 which is equal to 1, and tabulate values of y for x which is equal to 0, okay, to x which is equal to 0.3 and take h which is equal to 0.1. okay, so we have to use Euler method and need to solve this dy by dx as x plus y. Okay, now let me write what we have given. We have given dy by dx as a x plus y. Okay, and we are finding the solution for dy by dx which is equal to f of xy. Okay, so compare both of them. What will get the f of xy as a, what we get f of xy as a x plus y. Okay, divide by dx we get f of xy as a x plus y. Okay, yes, and y of 0 which is equal to 1 given, y of 0 which is equal to 1. Okay, y of 0 which is equal to 1, and we know that dy by dx has the initial condition y of x naught which is equal to y naught. Okay, these are the initial condition for this differential equation. So that means we compare y of x naught which is equal to y naught with this one. Okay, so y of x naught which is equal to y naught, so x naught is a 0, y naught is a 1. We got the x naught and y naught, both of these values over here. Okay, so x naught 0, y naught as a 1 here. Okay, yes, and h what we have, h is given 0.1. okay, h is equal to 0.1 given. Okay, this everything data we have, and plus x is a 0, we have to tabulate the value for x is a 0 to x is equal to 0.3. okay, x is equal to 0 to x which is equal to 0.3. so we have to tabulate the value between x is equal to 0 and 0.3. okay, so we have to consider x1, x2, x3, x4. okay, these are the value from x itself. Okay, so that we needed in Euler's modified formula. Okay, yes, so let's get start with the values of x. Okay, so x is a 0, that means x naught is a 0 up to 0.3, that means x1 is a 0.1, x2 is a 0.2, and x3 is a 0.3. okay, 0.1, 0, 0.1, 0.2, 0.3. These all are the value for x guys here. Okay, 0, 0.1, 0.2, 0.3 that we needed in our Euler's iteration. Okay, yes, so see that this is everything data we have given. So I compared this data with our last Euler method that I explained in my last lecture. Okay, yes, so let's get start our first iteration. What we have first iteration, we take first iteration as a y1 which is equal to y naught plus h times f of x naught y naught. okay, this one is our first iteration. So we write y1 which is equal to y naught. What is the value for y naught? Y naught we have 1. okay, so replace this value for y naught here, y naught plus h times h what we have 0.1. okay, I got the value for h. So after that multiplied by f of x naught y naught. okay, so we don't know the value for f of x naught y naught, but we have f of xy here. okay, so let me explain to you all how to find f of x naught y naught using f of xy. okay, so what we have f of xy, f of xy as x plus y. okay, and f of x naught y naught we write x naught plus y naught. okay, f of x naught y naught we write as x naught plus y naught. okay, so x naught plus y naught means 0 plus 1, 0 plus 1. so f of x naught y naught we got the 1. okay, this one is the value for f of x naught y naught. okay, I hope you all have understood how I have found this one. okay, yes, f of x naught y naught is 1. Okay, so put this one value here. Okay, so see that first iteration y1 we give this 1 plus 0.1 into 1 means 0.1. okay, 1 plus 0.1 we write 1.1. okay, we got the value for y1. okay, which is a 1.1. okay, so I got the value y1 as a 1.1. that means y of 0.1 as 1.1. okay, that means we can write this one, y of 0.1 is equal to 1.1. okay, this one is our first value. okay, let's go for the second one. What we have second iteration for our Euler method. So we write y2 which is equal to increase 1 y1 plus h as it is f of x naught y naught we take as the f of x1 y1. okay, we take f of x1 and y1. okay, yes, put the values in our given data. okay, so we need f of x1 y1 first. okay, y1 h it is everything there. okay, we need f of x1 y1. so f of xy we have x plus y. okay, then f of x1 comma y1 we write x1 plus y1. okay, x1 y1 I written here x1 plus y1. okay, so put the value x1 y1 over here. x1 is a 0.1. okay, so what we have x1 it is a 0.1. I already explained the value from 0 to 0.3 we have to take x0 x1 x2 x3. okay, x1 is a 0.1 plus y1 is 1.1. okay, 1.1. okay, 0.1 plus 1.1. okay, so go for adding them. 0. That means 1.2. okay, so after we write f of x1 y1 as a 1.2 over here. okay, 0.1 plus 1.1. okay, yes, so put all these values in our given result. y2 can be written as y1 1.1 plus h time, what is the value for h? 0.1 multiplied by f of x1 y1 is a 1.2. okay, is 1.2. and after adding everything we will get the value. You can use the calci guys, calci allowed here. okay, multiply both of them and then add it here. okay, so you will get the 1.22. okay, so this one is the value for y2. okay, so I got the value for y2 means y of 0.2 1.22. okay, yes, I got this value over here, y of 0.1 y of 0.2 as 1.22. okay, similarly do it for the third iteration. okay, that means third of value of Euler method y3 can be written as increase it 1 y2 plus h times f of x1 y1 we write f of x2 y2. okay, this one is the value for y3 over here. okay, yes, so put the remaining values here. okay, so what is the value for y2? See it here. What is the value for y2? We got the value for y2 is 1.22. okay, replace y2 as a 1.22. okay, plus h is a 0.1. okay, multiplied by f of x2 y2. so we have f of xy as a x plus y, f of x2 comma y2 as a x2 plus y2. okay, x2 plus y2. so what is the value for x2? Is a 0.2 plus y2 we have here 1.22. okay, add both of them, 0.2 plus 1.22. okay, so this one value you have to put here, 0.2 plus 1.22. this one is the value for f of x2 y2. use the calci, you will get the value 1.362. okay, 1.362. this one is the value for y3. okay, so this one is the value for y3 we got the 1.362. okay, so that means we got the y3 as 1.362, that which is equal to y of 0.3. okay, this one is the value of y of 0.3. okay, now see that these are the third iteration we required. So if you want you can go for one more iteration. okay, but not needed. okay, or not needed. These are the sufficient iteration for our Euler method. okay, I hope you all have understood guys my entire Euler method. If you want you can note it down. These are the very much important guys. I found most of the questions similar like this in your ENDSEM question paper. okay, note it down these points, it's as it is very much important. okay, see this is the example. After this the solution down here, you can pause the video, write it down these points it's needed guys for your ENDSEM exam. Okay, so I hope you all have understood guys my today's lecture completely here. Okay, it's not that difficult, it is one of the easy lecture guys. Okay, so even after if you found or if you have any doubt, difficulty, confusion, let me know in my comment section guys. I will come up with the similar videos. Okay, that's it for my today's lecture. So thank you everyone, thank you for my today's lecture.